Hey, this is Tay,
And this is Zach.
and this is our cloud computing project.
All right, for the introduction, this application that we are using for this project, we did not create it this semester. We took it from our 341 class, which was utilizing the Spring Framework. So we took that Spring application and we took it from the local environment that we had it running in. We took both the application and its backend database and put it up in the cloud. And just the purpose of this project pretty much was to learn how to make that transition from local to a cloud environment and why it's necessary and the challenges that we will face in the future, and just learn how to work with those.
Okay, so the objective of the class was for us to understand basic cloud computing concepts and technologies. So, how to put stuff into the cloud, the different types of clouds they were, the different cloud providers. So, we use Google Cloud, AWS, Azure, and Heroku. And we put projects into the cloud to gain exposure of how to deploy our applications, both just the regular code, but also how to connect our databases to it and how to understand how DevOps and build pipelines worked and all that, and how it would help us in a enterprise environment.
For the functional overview, we were making just a basic blog application with normal user functionality. So a user was able to log in and register an account so they could access information only to them based on a username and password they created. Have the ability to create, update, and delete posts, because you don't want to just be making something in a publicly viewable app that you can create and can do nothing to, maybe because it was defamatory, there was an error in it, or otherwise embarrassing. So we had that basic information. And then along with it, we had responsive pages via Bootstrap, so that it doesn't have to just be accessed by a computer with one specific screen type. It can be viewed by a large screen all the way down to like a smartphone, and all of the styling doesn't just go out of whack, and you have to use scroll bars on everything. For the features that we had fixed in this, was we had a jQuery pop-up that was going to be, every time you hit the delete button, just a little window would pop up and are you sure, and with the ability to cancel and delete. But for whatever reason, it was, instead of calling it for just one instance of the post, it would call it for all of them, and the delete wouldn't go. So we removed that. So it's just a basic hit delete and it deletes. There was also an issue where the first item on the list was unable to be deleted unless you went to the database and removed it. So we were able to fix that issue.
Okay, so for the UI design, we wanted to keep it minimal as possible, but also keeping it like aesthetically pleasing. So I think we did a decent job with that. It's just I didn't want a lot of a lot happening on the screen, because I know it could be like, really confusing if there's too much happening on the screen and the user doesn't know what to click and what to do what. And same way for like how we routed the application, we made it so that everything would go back to the previous page. So if you added a post, it would, instead of taking you to like a confirmation screen and then you have to go through the nav bar and all this other nonsense, it just took you back to wherever you were before. That way it just keeps it contained and the user doesn't have a bunch of pages to go through. And as said before, the Bootstrap pages, because since this application is in the cloud, it can be accessed from multiple types of devices by just the web address. So making sure that it looks nice on everything is really important, and keeping it like a clean look and just keeping the functionality as easy for the user as possible.
For our technical design decisions, we decided with the cloud platforms that Tay had mentioned earlier, AWS, Heroku, Azure, and Google Cloud, we decided to go with Heroku just because we felt that it was the most streamlined and the most easiest to use. Not because of like a separation of features, but we just felt like that it was the most straightforward, and it was the most descriptive on like how its tabs are all laid out. It was also good that we could connect a build pipeline up with GitHub very easily. All that we had to do was go into there, connect our GitHub account, and then select which repository we wanted, and then it would automatically do its builds and deployment off of that. So that was very nice. And then, as we said before, we use the Java Spring Framework just because it's the framework that we feel is the most robust and has the most options to it that we have learned at GCU, and so we were able to do that and build a nice application off of it. And then for the technical overview, here's all of the versions and such that we use for the application. So as I said before, we built in the Java Spring Framework, had a Tomcat server with a map to be able to connect to a MySQL database. We use Maven for our dependencies, and to access the database, we use PHPMyAdmin. And earlier I said we used Heroku for our cloud platform. We were able to create a build pipeline between GitHub and Heroku and use that for deployment. We used Uptime Robot to monitor the availability of the application. So if the application goes down, we can see that Uptime Robot will send us an email informing us, and then when it goes back up, it will also send us an email to tell us. And for our code repository, it was GitHub. That's just where we stored the code that Tay and I were able to both access no matter where we were. And we would go up there, pull any changes that were made before we start. We make whatever changes, and we push those changes back up there. And then for logging in the application, we leverage the SLF4J framework and put those logging statements throughout the application anytime there was a navigational point or any kind of an exception catch. And that was all captured by a logging drain set up in Loggly.
So when we originally made the app, we started off with the class models and kind of just went from there. So we did a login and registration first, just to get our hands on the database and how to use it with Spring. And then we updated that later to have dependency injection. And then later on, we added the ability to add posts and make sure everything was connected to the database properly, so that again, you weren't just getting random errors and it wasn't just hard-coded values and like a list in the code. And added the ability to update and delete the posts that were just made, and converted everything to a Maven project. So before, we had dependencies downloaded into the project itself, and then towards the end we switched over to Maven so that it took care of all of that and decreased the size of the project, but also making it easier for us to control the version of dependencies we want to use. And then for the cloud, we just put all of our hidden files for this project into a GitHub repo, and we made a new application in Heroku, linked everything together with the build pipeline that Zach was talking about earlier. And then we used the JAWS DB MySQL in Heroku and changed that application code to match the new database information, just to make sure everything was working correctly. And then for Spring, we needed to add a proc file to the GitHub repo to make sure everything was working correctly.
And to go over for the DevOps stuff that we added logging methods in our code, again, for any kind of navigational points or exception caches. We created a Loggly account to add the logging drain, so that not all of the logging files aren't just stored inside of either the root files of the application or in Heroku. They're also in a place where we can search for either specific times, specific words, whatever it is that we want to look for. Uptime Robot, again, that was linked to the application to see when it goes down and when it comes back up, and it lets us know when it happens so that we are able to be proactive with that, and we're not responding to a user emailing us saying that it's down.
All right, so for project limitations, there was just no search function at all, and there aren't session variables, so the users aren't being able to track, which means also any user can update or delete the posts. There isn't a way to regulate said users, and actually, this needs to come off of here now. The app is being hosted, but there is no security, and the users can only put in text.
Current bugs that we know of, it was similar to the option for the situation where the first item wouldn't be deleted. For whatever reason, the first item in the list of posts can't be edited. Not quite sure why, but when you hit the edit button on that first one, it makes a get when it should be a post call. All the other items call post. That one calls get. There's no get functions that it accesses, so it's just, yeah.
And future version ideas, just the main points we want session variables just to have the users be separated, ability to add more than just text, so like pictures, videos, and audio, the personalized page for the user, as well as being able to add it to a Docker container. So we want the whole project in a Docker container just to make it easier for development purposes and save time and money, because then developers don't have to try and download IDEs and versions and all of Java, and everything is just handled in Docker. So it's faster. And here's just how the Bootstrap pages look like. So this is what it would look like on an iPhone 7, I believe this was, the iPad Pro, and then just a desktop screen. So now I'm going to go to the demo. So Zach?
I will. So what we're going to do right now is Tay's going to go into one of the pages from our application. She's just going to add a space and then submit that, just so it's submitting a change. And then she's going to go into Heroku and wait for the build and deployment to start up. And this is just showing the build pipeline that we built between GitHub and Heroku. So whenever a push is made to the main branch of the application in GitHub, it will contact Heroku. Heroku will do a build to make sure that it can do a build. And then once that's done, it will deploy the application to make sure that with the changes that were made, it's still able to successfully build and deploy an application, and that if we make a change and it doesn't work, it doesn't just deploy a broken app that will just shut it down completely.
So the app just finished building right now, so we're gonna open it. And it's gonna take a cool minute because it just rebuilt, so it needs to update, and you're gonna get like the Spring errors. And you're gonna come here, and there you go. Database
and that's the main page. All right, so what she'll do next is she's going to hit submit with all empty containers to show data validation, which is spread throughout the entire application. Now we have all of the data forms filled in. We have an email there, jeff.richards@gmail.com, and the password. And for the phone number, it always checks that it's 10 digits, because if it's not 10 digits, then it's not a valid phone number. And that was just kind of one way to make it. All right, so go ahead, Tim. So that registered the new account, and she's now going to put in the information from it.
And it'll take you back here.
And yeah, we logged in with the newly created account.
So then also we wanted to add a post. There's the data validation. But so we wanted to say cloud presentation.
Cloud presentation.
That's not how you spell that. That's fine. It's okay. And then we can put in Heroku and you submit. And then here you go. Here's the newly added form. And then if you wanted to edit this one for whatever reason, add one to it. There you go. If you want to delete this, now it's gone. So
yep.
That was that part. And we're going to head over to Loggly now. And we're going to actually refresh this. And it's going to search for anything involving data service. So we have all of our post data services for find all, update, and delete, and all this fun stuff in here. And Zach, you want to say some more about it?
Yeah, so this is the logging drain that we had set up. So instead of having all of the logging files being left in the root files of the application or in Heroku, we have it set up so that Loggly captures all of those logging statements and documents in here, so that we can search through them either for a specific date, to see if it's coming from a specific controller, a certain action, an error maybe, and it just it makes it easier for multiple individuals to access.
Okay, and we're going to show it in here too, in Heroku, so
We'll show those logs as well.
there they are from the session that we just did. So as you can see, it went through delete and getting the posts and finding all this fun stuff. And then if we go to Uptime Robot, here is the monitoring system that we used. So these are the ups and downs. It was on from about 2 weeks ago when we did another milestone. So we had it up, and it's, as you can see over here, it's like 99% up, and it tells the user when it's down by an email address or an email address. It sends an email when the website goes down, and it'll send another email when it comes back up, so that we won't get angry users saying the website is down, or like lose money because the website's been down for like 5 hours and nobody knew about it. That type of situation. All right, and to conclude this lovely project, Zachary.
Yeah, to conclude, this project really taught us, the difficulties of transitioning from a local application to a cloud hosting application, but we also know the necessity of it, because when you're making local applications, you're really either making it just for yourself or you're testing. And once you want to get that application out to users and onto a market, transitioning to a cloud environment currently is one of the better ways to do it, instead of having to build your own personal server and allocating the space for it, purchasing the server units to be able to get it accessible to people, while putting it up in the cloud. There are a lot of popular tools that are out there that help you leverage logging, maintenance of the application, monitoring, all kinds of things that make putting an application up there simple for the developers and for everybody who's using it, and just how good of a resource cloud is today. And anything to add, Terry?
No, that was a pretty good definition. And that is our project for this year. We really enjoyed learning the clouds and how they work, and we all have had our favorites and stuff, but this was a good one, and that's pretty much it.
Yeah, and we will hopefully see you in, Senior Capstone 1 in the fall, if we ever get back to campus.